And good afternoon, guys. So, for our meeting for today, ang ating magiging pakay, saan ko kayo Tagalog? So, mag-recap tayo ng week 3, summarize lang natin, and hopefully ma-highlight natin yung mga important na concepts. Kasi kung nakita niyo na yung week 4 na activities, medyo may reliance siya doon sa mga kinover ng week 3 basically. And ayun, after nung ating summary ng week 3, we'll have a quick preview nung gagawin sa week 4. And ayun, so I guess let's start. So si week 3, it covers recursion. So coming from week 2 was algorithm analysis. So yung time complexity yun, di ba? So kung gaano kabilis bumagal, if that makes sense. So gaano kalaki yung pagbagal niya basically pag dumadami yung input. And that is for yung usual functions natin na may loops. And actually, yung mga loops natin siya yung nagkakos, di ba, ng dagdag na time. Kasi meron tayong inuulit-ulit. Another way for us to do the same thing or do multiple things with a single function call or a few lines is yung recursion. So instead na meron tayong loop na nag-iterate or umuulit, inuulit niya yung contents niya for a certain amount of time, yung ating recursion is calling itself multiple times. So ayun, baka medyo mas mahirap yung recursion when compared to loops or iteration. But it's not impossible. And hopefully, with this sa materials, ma-familiarize kayo kung paano ma-analyze yung ating mga recursive functions. So yung may konting kwento-kwento dito sa lecture ay sa study guide para naman di kayo naiinip, binabasa nyo lang naman. I guess ganito kasi naging style ko ng study guides ever since. So hindi ko siya matanggal. I feel like magandang may konting introduction para may konting background kung para saan ba yung materials for the week. And then may summary lang dito ng mga activities and assessments. So essentially, meron lang tayong isang main lecture notebook. Pwede siyang buksan sa Google Colab. And ayun, meron din actually nakitang website na can let you view yung mga notebooks ng maayos kahit nasa phone. Pero hindi ka nakakapag-run ng Python kasi nasa external website siya. Pero either way, ayun. Reconnect ko lang ito kasi kanina siya. So let's look at a specific example of recursion. For example, factorial. Ito na siguro yung pinakagasgas na example for recursion because n factorial is n times n minus 1 factorial. Pwede tayong gumawa ng function factorial na n times yung factorial ni n minus 1. Pero yun, kung napanood niyo yung video, may konting drama ako dyan. Hindi siya gumana. Kasi kailangan natin tinatawag na base case na if si n mas malaki kay 1, return 1 para hindi na tayo mag-continue on sa recursion. Kasi if hindi natin ito nilagay, tutuloy lang ng tutuloy yung recursion hanggang mauubusan ka ng memory. Pero yun, dito naman sa recursion, paano siya magiging useful? Kung wala, yun nga, kaya natin i-define yung function by itself or by yung definition ng function relies on the definition of the function. Kaya nga recursion. Pero yun, yung input natin lumiliit. So eventually, maabot siya sa point na tumitigil siyang mag-recursion. So to get yung ating time complexity ng isang recursive na function, magsisimula siya of course doon sa running time it mismo or yung pagbibilang natin ng mga commands or yung sa statements or instructions doon sa ating code. So, syempre dahil recursion, ang running time natin for factorial of n is equal dun sa running time no factorial of n minus 1 plus a certain constant. So, Ito yung tinatawag natin na recurrence relation, wherein nakikita natin yung relationship ng ating running time ng isang function with respect to itself. So since a function, a recursive function is a function defined by itself, by using itself, ang ating running time ng ating recursive function is also defined using itself to what we call as the recurrence relation. Now, ito, medyo, okay, it makes sense. Yung running time ni factorial n equal siya sa n minus 1 plus yung constant. Pero paano ko malalaman yung time complexity ng ating function? So, may different number of ways. Actually, up to 3. Pero dalawa lang yung covered for week 3. Yung first way natin is yung tinatawag na substitution method. So the substitution method works like this. Magsa-start ka with the recurrence relation and i-expand mo siya, basically. So si t of n minus 1 equal siya kay t of n minus 2 plus c. And so si t of n, eventually, pag in-expand ko si t of n minus 1, magiging t of n minus 2 plus 2c siya. Nag-gets naman kung bakit siya naging. And then itong nasa loob, pwede ko siyang expand ulit. T of n minus 3 plus c. And then yung aking t of n equal na siya kay t of n minus 3 plus 3c. And eventually, pag kinontinue natin yung pag-expand and pag-expand, may t of n minus 4, t of n minus 5, and si c magiging 4 and 5 din respectively. So may nakikita tayong pattern. Pwede nating i-generalize or i-generalize yung expression for t of n as t of n minus k plus k times c1. Kasi kung ano yung sinusubtract natin sa loob, yun din yung ina-add natin kay c1. So, merong formal way para i-defend or i-justify na si t of n. So basically yung jump kasi from here to here is medyo vague. So parang pattern, naghanap ka lang talaga ng pattern. Kung dadaan na kasi natin yung formal way to get it, kailangan nyo ng parang higher and more formal algebraic proof na courses na ano mo time para doon. So basta makita mo yung pattern, okay na yun. Mukha naman, basta ma-verify mo with the next few examples. So, baka gumawa ka ng expression, hindi pala siya true for some expansions ditong term. Okay, hindi siya totoo. Pero ito, pag si n-6, alam mo na 6c1 siya. Pag n-10, magiging 10c1 siya. So, more or less, medyo confident naman na tayo na ito yung form niya basically. So, nag-substitute tayo ng k to a certain constant doon sa recurrence relation na expanded. And yan, t of n minus k plus kc1, yung t of n. Now, ang next step, substitution method, si n minus k, isa-substitute natin to k equals n minus 1. So, bakit kaya natin ginawa yon? So, sinubstitute natin si k to n minus 1 para yung nandito sa loob. So, si n minus n minus 1 or yung k, eventually, pag in-add up natin sila, magiging t of 1 siya. And then yung k term dito sa labas, n of n minus 1, so malalating lang yan dito. So anong significance ito? Ba't natin siya gustong gawing t of 1? So recall, yung recurrence relation natin, meron siyang dalawang parts. So yung recursive call and yung base case natin dito. It's another constant. So just like yung ating function, gusto natin siyang i-call niya yung sarili niya hanggang umabot sa base case. Ito, mag-expand siya hanggang makaabot siya dun sa base case. And gusto lang natin maging generic dito na letter K yung gamit natin, hindi specific dun sa N. And ayun, once we get that, si t of 1, pwede natin siyang i-substitute na or i-replace with C2. And then we are left with t of n equals C2 plus n minus 1 times C. And ito na yung running time or yung number of instructions natin. And we can use our asymptotic analysis now on it. So, asymptotic analysis, kunin lang natin yung largest growing term, which is n, and we get yung ating running time for the factorial function as O of n, or linear. So, may questions ba so far? Mukha namang malinaw yung steps. So parang step 1 is to expand our recurrence relation. Step 2 is to make a general form ng ating expression na magiging true after any number of times natin expand yung ating recurrence relation. And then yung third step is to, once we get the general expression, yung term sa loob ng T or ng recursive na call, i-equate natin siya dun sa base case. And when we equate it to the base case, eventually makukuha natin T of n na wala ng recursive call. And makukuha natin yung overall time complexity niya by the end. Ayan. So moving on to the next method, which is the recursion tree method. Gagamit tayo ng ibang function for this. So this function is called binary, and it prints all the n-digit na binary numbers. So pag binary 3, lahat ng 3-digit na binary numbers. Pag binary 4, hintayin natin dito, lahat ng 4-digit na binary numbers. So ano yung ibig sabihin ng code niya? So essentially, dito sa line na to, we add 0 to all binary numbers, or to all n-1 digit binary numbers. So, di ba si binary n, lahat ng n digits, si binary n-1, lahat ng n-1 digits. So, lahat ng n-1 digits, lagyan ko ng 0, and then pwede ko rin dito sa second line, mag-add naman ng 1, makukuha ko lahat ng n-digit na binary numbers. Kasi may n-1 digit binary number ako, dinagdagan ko ng isang digit, may n-digit siya. So, basically, yung concept niya is ganon. So, lahat ng 4-digit na binary numbers, kailangan natin ng 3-digit na binary numbers, and nag-append tayo sa kanila. Now, ano yung recurrence relation nito? So, notice here na meron tayong dalawang recursive call na n-1 yung bagong input. So, 2 times n-1 yung makikita natin sa recurrence relation. And then, medyo generic tayo dito. F of n lang muna yung ginamit natin to symbolize yung running time ng pagko-concatenate ng strings dito. Kasi, depende sa system mo kung Python 2, Python 3, actually kahit Python 3.2 to basta ibang version ng Python, hindi pare-pareho yung running time nila. And lalo na pag pumunta ka pa into C or C++, ang pag-add or pag-concatenate ng string is rarely a constant na operation. So ginawa ko muna siyang generic na f of n para din makita niyo yung nangyayari pag gumawa tayo ng tinatawag na recursion tree. Then yung sa base case then is g of x kasi ayaw pa naman natin magpakasigurado kung ano yung running time print operation. So ayun, ang recursion tree natin basically parang tinatabulate or dinodraw out natin yung number of instructions per recursive call. So baka medyo mabilis yung animation dito, and even with sa videos na pinrovide ko, merong slower version. So starting from t of n, equal siya kay 2 times t of n-1 plus f of n. So yun na yung starting point natin. So pwede nating expand yung term na to sa gitna. Yung 2 times t of n-1 is dalawang 2t n-2 plus f of n-1, and 2 times t of n-2 plus f of n-1. And then since itong term na to, nilagay natin dito sa baba, tatanggalin na natin siya sa taas. So yung matitira dun sa taas is f of n. Similarly, yung sa next step, pwede kong i-expand yung t of n-2 term na to into 2 instances ng t of n minus 3. Tapos yung f of n niya is n minus 2 na. And so on and so forth. Makikita nyo dyan is ang magsa-stock dito is yung f of n sa first level, and then sa next level si f of n minus 1, and then si f of n minus 2, and si f of n minus 3. Eventually, mapupuno mo siya na ganyan. So parang per step, nababawasan ng isa si n sa loob, pero dumodoble yung dami niya. So this is what we call the recurrence tree. And to describe the tree, we usually consider, or actually to get the total number of instructions, we just have to add all of the nodes dito sa ating tree. And then to make things a bit more systematic, tinitignan natin yung tree in terms of their levels. So yung starting point natin is level 0, the next level is level 1, 2, 3, and then yung last level, tinatawag natin yung D, or the depth, or ang total number, or it is also the total number of levels, or yung recursion stages, essentially, ng ating function. Bakit siya useful tingnan as levels? Kasi tingnan natin dito, lahat ng level 0, f of n, lahat ng level 1, n minus 1, lahat ng level 3, n minus 3, and then lahat ng level k, a n minus k, and then another thing is, first level is 1 element, level 1 is 2 elements, level 2 is 4, level 3 is 8. So, makikita nyo dito, dun sa ating material, per level, kaya mong sabihin na yung total na runtime per level is 2 to the k times f of n minus k. So, ito yung step na medyo similar kay substitution method. Kailangan natin makakuha ng expression ng per level ng recursion tree. Hindi siya required, but it's the systematic way of getting it. Pwede mo naman bilangin na lang isa-isa, pero ikaw, technique mo. Paraanan mo, paano mo matutotal lahat ng yan? So, given this expression ng total runtime per level, we can put the total runtime, or we can express our total runtime as yung summation ng itong expression na to. And then note that we assume that f of n is just a constant operation. So, si 2 to the k na multiplied na lang kay c. And then lastly, yung last level, siya yung ating base case. So dito, meron tayong 2 to the 3 na 2 to the 3 na instances, basically. So at the level D, meron tayong 2 to the D instances of g of x. So, yun nandito. Diyan. Then, ayun, what's next is to get yung ating expression for D. So, D can be obtained in a number of ways. Yung dito is in-observe ngayon sa last line. Dahil yun dito, lahat n minus k, n minus k. So, dapat si 1 equal din siya kay n minus k. Pero ang level niya is d minus 1. So, kailangan si n minus d minus 1 is equal to 1. So, essentially, d is equal to n. And once we get that, we substitute it back here, dun sa summation. And then note na nag-simplify tayo ng summation ng 2 to the k as 2 to the n minus 1. And then 2 to the n minus 1 times c, and then 2 to the n times g of x. So, open ko yun. And ayun, since we know d, that's n, eventually makukuha natin na ito nga yung running time. And pagkakuha ng big O, we get na, well, actually, n g of x times 2 to the n to, if gusto mo maging mas specific. Pero pag kumari, si g of x is just O of 1, 2 to the n to, pero assuming na g of x is n, n 2 to the n siya. So, any questions here? So, medyo graphical yung approach. In such a way na sinusulat natin in a structure. yung ina-add up natin. Dito is parang number manipulation. Ito is parang sinusulat natin. And then, ayun, ito rin yung main topic ng formative quiz for week 3, which I think we can cover din naman for this session. Kaya doon, sinet up ko yung whiteboard ko. So, first time siya ginawa. The second time kasi ginawa siya. Kung wala pang answer dito, para hindi tayo ma-spoil. And then, I just need to zoom this in para lumaki. Yeah, sagad mo. So, ating first recurrentialization. So basically, kinukuha natin yung big O ng mga recurrentialization na nasa quiz. So, yeah. For the first recurrentialization, I hope kita pa rin siya kahit na ginulit. I-write ko na lang dito. So, let's say T of N. Okay naman na yung laki. Pag nilakihan ko kasi, baka mapuno agad. Okay. So, may mga nagda-like naman. Okay. So, T of N is equal to T of N over 2 plus N. So, if you want to use yung substitution method, so dapat pala mas nakita ko. If you want to use the substitution method, ang first step is mag-expand para makuha natin yung pattern natin. So, una, i-expand natin yung term na to, T of N over 2. So, we should get na T of N over 2 is equal to, parang, di ba si T of N over 2 plus N. So, pag N over 2 yung sa loob, we get na T of N over 4 plus N over 2. Okay pa yun? And then, pag sinubstitute natin siya pabalik doon sa unang expression, we get T of N is equal to yung T of N over 4 plus N over 2. Then, yung plus N dun sa dulo. So, sinubstitute ko lang ito doon. Ngayon ko lang ginawa. Check ko lang. Then eventually, pag in-expand natin siya ng isa pang step, we should be able to deduce na yung nandito sa loob ang matitira is N over 8. And yung ating term dito sa right side is another term, the N. Pero yun, yung una is 1N, then plus 1/2. And then yung next one is plus 1/4. Nakuha naman yun. And then, medyo di na. Ayan, kita pa dyan. The next naman is the N over 16 plus N, 1 plus dot hanggang 1 over 8. So, the next step natin is yung ating kutuban. Pattern finding. So, kung ano yung huli mong dinivide dito sa loob ng T term, siya yung ina-add natin doon sa next na item basically doon sa list. And then, yung ating term is nag-start from 2, and then 4, and then 8, and then 16. So, powers of 2. So, we can express yung ating T of N as T being divided by a power of 2, 2 to the K. So, nag-start ka at K equals 1, then K equals 2, ito si K equals 3, ito si K equals 4. And si N naman, 1 plus 1 over 2 plus dot, 1 over 2 to the K. Pero, hindi pa kasama si 2 to the K, yung 2 to the K minus 1. Okay. So, yeah. Hopefully, clear sa inyo? Or I guess may idea kayo paano nag-jump from this expression over here sa baba to this general equation dito sa taas. So what's left for us now is to simplify itong dito sa taas. Siguro before we do that, itong nandito sa right term is a geometric series. Tama? So this is a summation of 1 over 2 to the I, where I is equal to 0 hanggang k minus 1. And then, if familiar kayo sa mga summations nyo, I think this is, syempre may konti ko ako, hindi nakikita. This is equal to 2 minus 1 to the 2 to the k minus 1. So basically, and k, yung original nila is 1 minus 2 to the r, ay 1 minus 1 over r to the k plus 1 minus r, or 1 minus 1 half. So yung bottom term natin dito is just 2. So multiply lang yung 2 dito sa taas. So that is two minus 2 to the k minus 1. Pwede tayo magdagdag ng 2 sa taas, 2 sa baba, para maging 2 to the k na lang siya. So 4 over 2 to the k over there. So, paano pwede natin i-rewrite to? Yung nasa loob as just n times 2 minus 4 over 2 to the k. Para kasi madali lang kasi may 2 to the k tayo dito. So, 2 to the k natin. So, what's next? Ito, gusto natin mag-equal siya kay 1. So, n over 2k should be equal to 1. Therefore, n is equal to 2 to the k. So, bakit siya equal kay 1? Kasi gusto natin dito, if makikita nyo yung sa recurrence relation natin, at n is equal to 1, or yung basically yung input natin sa kay t is equal to 1, may O of 1 tayo. So, pag ito sinubstitute na natin dito, we get that t of n is equal to t of 1 plus n times 2 minus. So, si t to the k, puro siya n, no? So, 4 over n. And si t of 1 ay basically O of 1, sabi ni given, and then this other term is 2n minus 4. So, pag kinuha natin yung big O, itong buong expression, we get O of n, or dr. And ay, may nagtanong pala, saan daw galing yung denominator kanina, yung 1 minus 1 half? So, going back, yun yung dito sa expression kanina dito pa. So, sa math, pag meron tayong summation from, hindi ko sure kung I equals 0, I equals 1 hanggang k of 1 over 2 to the I, or r to the I. Ang equation, ang formula nito is 1 minus r to the k all over 1 minus r. So yung 1 minus 1 half sa baba, ay, hindi pala siya. Ri lang pala to. So pag naging 1 over Ri, this is magiging 1 over R, 1 over Rk. So basically, equation lang siya ng summation. So hindi siya, essentially hindi siya related sa topic natin. Pero, ayun. Kaya natin, alam ko prereq naman. I guess kung hindi nyo naman alam, search naman. Search lang geometric, sum of a geometric series. Kasi ako, actually, nung ginagawa ko yung solution nito, sinerch ko pa rin siya. So, nalaglag ko yung sarili ko. Okay, yun. So, yung sagot natin dito is O of n. So, sa instructions, hindi mo na kailangan lagay si O. Answer without the big O. So, yung n na yung kailangan yung ilagay dyan. Then, for the next one, siguro para magamit natin yung other method. Oh, so, pwede nyo rin gamitin yung tree method dito. Kaso hindi ka makakabuo ng tree kasi isa lang naman siya. Or if gusto nyo makita yung sa tree, parang ano lang siya. Parang stick siya, hindi siya tree. So, magsa-start ka lang with n, magiging n over 2, magiging n over 4, magiging n over 8. So, yan, makukuha nyo lang dito is yung same term, summation ng n times 1 over 2 to the I equals 0 hanggang yung depth natin. Pero makukuha nyo naman dito yung depth din natin is equal to log n. Pero before nun, ito is magiging, ayun na din, n times 1 minus I over 1 minus 1 half. And eventually, makukuha nyo rin na. Okay. So on and so forth. Para sa dami tayo sa actually dalawa. So yung for the next recurrence relation, imbis na over 2, it's over 4. And naka-multiply yung 4 dito sa labas. So 4 yung na-spawn. Nasa spawn. Kasi ayun, if gagamitin natin yung recursion tree, we start with yung f of n natin na n. Pwede yung lagyan ng extra squares, circles, or whatever. Basta maging clear kung ano yung magkaka-level. So si t of n, gagawa siya ng 4 na t of n over 4. So 1, 2, 3, 4. And kada nagawa niyang t of n over 4, meron siyang n over 4 na term. So bakit n over 4? Kasi pag kinuha natin si t of n over 4, that is 4 times t of n over 16 plus n over 4. So without this part, yung recursive part, ang natitira sa atin is n over 4. So hopefully malinaw. Yun. So at this point, hindi na ako nag-rehearse ng kulay. So baka isang kulay na lang. Okay, other considerations, kung ano naging n squared to, so lahat ng mga terms natin dito, magkakaroon lang ng squared dyan. Tapos, ayun. Mahirap pa dito, walang control Z. Buburin ko lang. So, continuing with our expansion ng ating recursion tree. Itong n over 4 is gagawa din siya ng 4 na terms. Naubusan na ako ng space. Yung n over 4, gagawa siya ng n over 16, n over 16, n over 16, at n over 16. Hello. And then yung next, gagawin na rin siya 1, 2, 3, 4, n over 16, n over 16, n over 16, n over 16. Pero basically, nakikita nyo naman, ito nag-split sa 4 na n over 4. So yung total pa rin natin, so yung total natin, bigay natin dito, total. Ang total natin dito is n. Ang total natin dito is also n. And then this one, meron tayong 4 na 1 over 16 dito, 4 na 1 over 16 dito, 4 na 1 over 16, 4 na 1 over 16. So, hindi makuha natin. It's also just n. Kasi mag-split ka to 4, pero yung kada 4 is over 4. So yung ating mga per level or yung per node is mas-split to 4, pero 4 din yung nagagawa. So yung total natin is n. So n yan hanggang makarating sa dulo. So hindi na ako siya. Pero eventually, aabot to dun sa point na magiging 1 na lang siya. And ilan yung mga matitirang 1 sa dulo? Kasi ito is magsuspawn siya ng mga 1, ito rin magsuspawn siya ng mga 1, ito rin gagawa siya ng mga 1. So ilan yung mga 1 natin sa dulo? So pwede natin isipin, bilangin natin, dito is 1 element or 1 node. Dito is 4 nodes. Dito is 16 nodes. Ito is something to the power of 4 to the nth power. Or, di ba, yung ating last level, we consider it as level D. So, kung yung level, this is level 0, level 1, this is level 2. Yung last level natin is level D. And then for each level, meron tayong 4 to the 0 na elements, meron tayong 4 to the 1, meron tayong 4 squared na elements, so meron tayong 4 to the D elements na 1 dito sa dulo. So, for D minus 1, meron lang tayong puro N. Pasensya na, di kasi yung buong tree. So, for the actual tree, meron tayong D minus 1 levels na puro N yung total. And then for the last level, meron tayong 4 to the D na elements na O of 1. So, ito ang ating D of N. And then, makuha natin dito yung depth is yung number of levels. So, in order to reach yung 1, di ba yung terms natin kanina is n, tapos n over 4. So, nag-start yung tree natin with n, and then naging n over 4, and then naging n over 16. So, basically, yung n naging over yung kanyang level. So, n over 2 to the level. So, for the last level, yung n natin eventually naging 1. So, ang ating 2 to the depth ay equal kay 1 din. And then, simplifying this, uh, 2 to the d equals n. So 2 to the d equals n, and then d is equal to log n. Substituting this to our t of n, we get that log n minus 1 times n plus, so ay ba't naging 2? Ito ang nagsabi, 4. So log base 4, ito, and then plus, so si 4 to the d ay equal kay n plus n. So this is n log n minus n plus n. So you see minus n plus n cancel out. So yung ating big O ay n log n. Okay pa ba yun? Okay. I guess meron naman tayong similar na recurrence relation pagdating sa week 4. And mas na-explain ko yun in detail dun sa mga materials. Pero yun, ayun, meron pang last item dito sa formative. So this one is n times log. So pwede yung click yung display response. Makuha niyo yung expression mo. Excuse me. Now this last one, kamukha niya si binary. Pero in this case, 2 yung kay binary. Pero dito is times 4. So actually kung buko niyo dito, ang sagot is n to the times 4 to the n. Because ayun, pwede nyo gamitin yung same process. And eventually is yung makukuha nyo dito, instead na 4 times f of n, magiging, imbis na 2 to the k, magiging 4 to the k. And yung magiging result na is n times 4 to the n. Okay. So, finishing the attempt. Something pa suspense. And then, no, tama naman silang tatlo. Okay. So yeah, actually yun lang naman yung main thing for recursion, yung ating pagkuha ng time complexity. The second thing is yung ating space complexity. Since recursive functions, pag hindi pa natatapos yung function, is na kikip sila dun sa ating program stack. So the more recursive calls, the more memories na gagamit mo sa ating program stack. So essentially, kung wari ito, si factorial, kung ilang beses natin siya kinol, yun yung space complexity natin. So O of n. However, kung wari ito, yung nagba-branch out, kung sa binary, makikita natin na yung memory na ginagamit natin, up to a certain degree lang, actually, from one path, from our initial na recursive call hanggang sa isa sa dulo or isang node dun sa depth, hanggang dun lang yung ginagamit na memory. Kasi pagdating naman natin sa dulo ng ating recursion tree, babalik siya doon sa nauna sa kanya, so mawawala na yung memory na gamit niya and tsaka mapupuno. So when we consider yung memory consumption ng ating recursive na algorithm, kailangan lang natin i-consider yung isang tuloy-tuloy na recursion hanggang dulo. So for example, ito yun, nag-start tayo with binary n to n minus 1, n minus 2, n minus 3 hanggang 0. So hindi natin kailangan i-split up pa yung 3 kasi hindi naman basically hindi naman sila nagkikita in memory. So yung mga magkikita lang is yung mga tuloy-tuloy sa isang basically isang branch. So kung wari 3 to, di ba? So, yung isang branch is yung tuloy-tuloy na pababa. So similar dun sa recursion tree method, kailangan lang natin bilangin yung total na memory consumption. So starting with the first level, C1, wala naman siya extra space na ginamit. For binary n-1, gumamit siya ng extra space para i-store C1. Dito naman, gumamit tayo ng twice ng extra space kasi 1, 1 yung kailangan i-store. And then dito, thrice, kasi 3 characters na yung kailangan i-store. And eventually, kung ilang digits yung ating number, ganun kadaming extra space to store it. So, kailangan na natin i-set up yung summation nito. So, yung C1 times the number of levels or depth, and then summation ng KC2 from K equals 0 to K equals D. So, in this case, excuse me, yung ating space complexity ay big O of n plus n times n plus 1 all over 2, or O of n squared. So yun, parang similar lang siya sa recursion tree. Pero sa tree kasi, di ba, ina-expand natin siya. Dito naman sa memory is isang linya lang yung tinitingnan natin. Pero tinitingnan natin yung extra space na ginagamit at hindi yung number of operations. And ayun, yung last part lang dito is a couple of notes sa paggamit ng recursion. Sometimes recursion makes things better, sometimes hindi masyado, and sometimes nakakadali lang siya for us to write our programs, lalo na if kaya natin siyang i-define using itself. Makikita natin yun actually sa week 4. But in either case, to definitely say kung alin yung better, we usually resort to yung pag-compare ng complexities. So, ayan. Pagdating dun sa factorial na function, yung iterative na implementation ng factorial, hindi siya gumagamit ng extra memory. Or I guess yung extra memory na ginagamit niya is constant lang. So, so yung iterative na factorial natin na function is actually a bit better in terms of memory consumption kasi pareho lang sila ng time complexity. So almost always ito yung gagamitin. Now for the iterative version ng binary, medyo mas complex siya kasi medyo mas mahirap isipin yung paano mo ba magagawa yung without, by staying true or by still following yung concept na lahat ng n-digit na binary numbers, gawa lang sila ng mga n-1 digit na binary numbers. So basically, applying that formula or that procedure dito, ito yung makukuha mong function. And medyo mas mahirap siya intindihin compared doon sa recursive na function. So doon pa lang, siguro as a programmer, baka mas prefer mo gamitin yung recursion. And then looking at yung time complexity niya is pareho lang, n times 2 to the n. And yung parang kicker na lang natin dito is yung memory. So yung space complexity ng iterative na solution is n to 2 to the n din. So medyo madaking space yung ginagamit niya. But yun nga, yung ating original na recursive function, quadratic lang siya. So that's definitely better. Pero of course, pwede ka naman magkaroon ng ibang iterative na solution. Pero yung pag-iisip pa ng ibang iterative na solution, parang extra work yun para sa'yo as a programmer. Pero hindi siya extra work para sa computer. So yun na lang. Sino na lang yung magsasuffer? Ikaw or yung computer? And then anyway, ayan, one of the few or one of the most useful cases for recursion is yung tinatawag natin ng backtracking. So, yung makikita nyo dito, Instead of, nakakuha na tayo ng 3-digit na binary number, instead of gumawa siya ng bagong 3-digit na binary number, parang magba-backtrack siya. So, i-undo niya yung huli niyang nilagay and maglalagay siya ng ibang number. So, instead of creating another 3-digit na binary number, kukuha na lang siya ng, babalik siya as 2-digit bago magiging 3-digit siya ulit. So, parang yung tinatawag natin ng backtracking. After mo maka-reach dun sa dulo, mag-undo ka ng isang operation and gagawa ka ng ibang operation. So, useful siya if kailangan mo ng, or kailangan mong daanan lahat ng possible combinations or yung mga ganong, or lahat ng possible combinations, lahat ng or pag kumari meron tayong series of steps na ginagawa, kung gusto nating instead na mag-start ulit sa simula, pwedeng i-undo mo lang yung last step na ginawa mo and ayun, meron ka ng bagong solution. So, ayun. So, ito lang basically summary ng lahat ng nandito sa document. So, yun yung ating summary of the recursion materials for week 3. So, at this point, may questions ba tayo? So, si week 3, meron siyang tatlong assessments. Isang formative quiz na ungraded, yung nga ginaan natin kanina. Yung summative quiz, para siyang yung ginawa natin dito sa notebook. Meron tayong isang function. Para yun, yung binary, kunuha yung time complexity, space complexity, etc. And then we have, lastly, a coding exercise na required kayo gumamit ng recursion. Kasi syempre, tungkol sa recursion ng week. So, why not? So, for the exercise, ang kailangan nyo magawa is for a given input, kailangan nyo makuha lahat ng same digits, or same number of digits, and then same sum ng digits. So, pag ang input ay OX8F, meron tayong 7 other hexadecimal numbers na same yung total. So, yun yung output natin. And then yun, we should implement recursion. So, if yung implementation, pwedeng maka 100% kayo sa hacker rank, 40 or 20/20. Pero if purely iterative yung solution nyo, it would receive a 50% deduction pagka-record sa UVLE. So, ayan, pagbabasehan mo, also kung non-recursive yung implementation mo, tapos hindi mo pa napasa lahat ng test cases, kung 10/20 ka lang, ang marirecord sa UVLE ay 5/20. So, gano'n. So, kung maka 10/20 ka na recursive na algorithm, edi, ayun. Congratulations. Okay. So, siguro, what's next for us now is to have a preview no week 4 na activities or week 4 na materials. Kasi, technically speaking, week 4 na tayo, pero deadline ng week 3 activities bukas. So, ang week 4 is on divide and conquer. And yun din, may isang lecture notebook lang, similar to recursion. So, divide and conquer is a programming or problem-solving paradigm, or it's a way to solve a problem. Hindi naman siya fixed for programming. So, ang gist niya or key aspect niya is from a problem, dinidivide natin siya into smaller sub-problems. And yung sub-problems is, pwede pa natin siya i-divide further. And once yung ating divided na problem ay maliit enough at madali na siyang isolve, pwede natin siya ma-conquer. And yung sub-problems na isang problem, pag na-conquer na natin lahat, i-combine natin yung mga solutions nila to solve yung ating bigger na sub-problem and eventually ma-solve yung biggest problem natin of them all. So, ayun, basically, ang material for this week is 3 different examples na gumagamit ng divide and conquer na paradigm ng pag-solve, basically. So, the first one is yung pag-search sa isang sorted na list. So, pwede naman natin i-check isa-isa yung mga elements sa list. Pag meron nag-equal, ayun, nahanap na natin siya. Pero since sorted yung list, pwede natin gamitin yung to our advantage and use yung tinatawag na binary search. So, for in binary search, starting with the initial list, since sorted tayo, pwede naman natin i-check yung first element lang. So, for example, hinahanap natin si 9932. Check natin yung middle element. So, for example, sakto sa gitna. So, for example, check natin siya. I-compare natin siya kay 6769. So, si 9932 ay mas malaki. So, we can divide our list. So, meron akong 2 halves ng aking list. Lahat ng mas malaki kay 6769, lahat ng mas maliit kay 6769. Kinompare ko si 9932 kay 769, 6769. And it turns out na mas malaki siya. So, we can say na hindi na natin kailangan yung ating nasa left ni 6769. And dito, sa right list na to, makikita si 9932. So, what's next dito is ulitin mo lang yung algorithm. Hatiin natin yung list into 2. And then tignan natin yung middle element. I-compare natin kay 9932. Mas malaki pa rin. So we can discard yung left elements over here. And dito na lang ako mag-search. So in this way, parang every time na mag-compare ako, kalahati ng elements ko natatanggal din sa aking list. And ayun, it has a recursive, you can have a recursive implementation. So, una, di ba chinek mo sa gitna? So, sinabi mo, wala siya dito sa upper half, nandito siya sa lower half. So, paano natin siya hanapin sa lower half? We also apply yung binary search. So, first, magba-binary search ka for n items, and then magba-binary search ka for n over 2 items, and then binary search for n over 4, n over 8, etc. and etc. So, doon pumapasok yung ating recursion. So, yung binary search from 0 to n and either be a binary search or, ayan, yung binary search from 0 to n, pwede niya i-call yung binary search from middle to end or yung start to middle, depending on dun sa comparison ng middle element. So, kung makikita nyo yung recurrent solution nito is magiging T of n is equal to T of n over 2 plus C1, which is similar dun sa, well, hindi naman totally similar, pero kamukha nyo yung nandun sa formative quiz natin. And then ito, using substitution, makukuha nyo eventually na yung ating T of n is logarithmic, or ayun, so yung ating linear search na O of n is mas mabagal kaysa kay binary search na O of log n. And then looking at yung kanyang auxiliary space complexity, since constant lang yung space na kailangan lang talaga natin makuha yung depth or yung, and then yung depth natin is just equal to log of n. So yung memory space natin is log of n. So, ayun, comparing it, yung linear search natin, constant O of n yung time niya, pero constant naman yung space na gamit niya. Tapos si recursive na implementation is log n si running time and log n din si space complexity. So basically, nagbabayad tayo ng konting space to have a faster na algorithm. Although, ayun, nasa iyo naman yung choice kung alin yung willing mo i-give up. Pero ayun, another option si binary search, baka pwede naman natin siyang implement without recursion. So hindi naman requirement i-divide and conquer ang recursion. Pero it helps. So for example, yung sa ating next na algorithm, yung tinatawag na merge sort, ang ginagawa natin is yung isang list, ipapartition natin siya into 2. And yung dalawang list na yon isa-sort natin. And then pag na-sort na yung dalawang list na yon, i-merge natin sila. So pag meron kasi tayong dalawang sorted na list, madali na lang siyang i-combine to another sorted na list. So yung dalawang partition, paano natin i-sort? So as you may have guessed it, isa-sort natin yung mga partitions using merge sort. So yung merge sort, yun nga, hatiin natin yung list into 2 and isa-sort natin yung mga partitions niya. Paano natin isa-sort yung partitions niya? Merge sort. So paano natin na-apply yung merge sort? Ay, medyo ulit. But yun yung point ni merge sort. And bakit useful sa kanya yung gumamit ng recursion. So looking at yung code niya over here or yung sample implementation niya over here, yung ating recursive na merge sort, dito na sa part na to. Basically yun, hanapin yung middle element and then i-sort yung left partition or lower partition and then i-sort yung right partition and then i-merge sila. And yun na yung i-return kay sa nag-call essentially. So, ayun. Ano yung running time? Paano ito magsasort? Merge sort pa rin. So, yung running time naman natin is meron tayong dalawang recursive calls dito na yung elements ay kalahati ng original number of elements. So, T of n is equal to 2 times T of n over 2 plus meron tayong extra function na ginamit which is yung merge na ayun, kailangan nyo i-observe. Meron tayong dalawang sorted na list para i-merge sa kanila is co-compare lang naman natin yung smallest element sa kanila. So dito, sa specific step na to, i-compare lang natin si 19 at saka si 26. And since si 19 yung mas maliit, sure tayo na siya yung next element doon sa merged na list na sorted. So makikita nyo dapat na ang running time nitong function na to ay O of n. So, or linear. So, since linear si merge, ang ating recurrence relation would finally look like 2 times t to the n over 2 plus n plus c1. So, ito lang using yung ating recursion tree, makukuha nyo eventually na yung kanyang running time ay log linear or n log n. So, yung n log n, mas mabilis siya kay n squared, which is yung mga na-encounter nila na sorting algorithms like insertion sort, bubble sort, and selection sort. So, significant yung matitipid natin dito. Kasi imagine nyo na lang, let's say n is equal to 1024. Ang n squared is approximately 1 million, 10 to the 6. Pero ang n log n na base 2, well, hindi naman important na base 2, pero for this example, base 2 siya. Ang n log n natin is just 1024 times n. So, nasa 10,000 lang. So, 10 to the 4. So, comparing it, yung n log n natin is 100 times smaller than yung n squared na term. So, that's a big step up actually. Very significant change. However, ano yung cost natin? Paano natin napabilis yung pag-sort? It's because gumamit tayo ng additional na memory. Now, since dalawa yung functions natin dito, meron tayong yung merge sort at saka yung merge, dalawa yung memory na kailangan natin consider. Yung memory ng recursion at saka yung memory ng merge. So getting yung memory ng recursion, if you can recall dun sa ating implementation, meron tayong dalawang temporary na list dito, si left at si right, and sinustore nila yung mga sorted na partitions ng mga recursive na function call. So, ang memory consumption natin for the merge sort or yung sa recursive na function calls is from merge n, kailangan natin ng dalawang n over 2 na list. For merge sort n over 2, kailangan natin ng dalawang n over 4. For n over 4 na merge sort, kailangan natin dalawang n over 8, and so on and so forth. So yung total na memory for recursion natin is in this term, C1 times log n plus 2n minus 1 C2. And then yung for merge operation, yung sa other function natin na merge, may kita nyo dito, it has a temporary list over here, and it will at worst contain the elements, all the elements of A and all the elements of B. So yung total number of elements is n. So yung memory natin for the merge operation is O of n. Yung memory natin for the recursion is log n plus 2n. And overall, yung ating space complexity ay O of n. So, if you can recall, yung mga n-squared na sorting algorithms, lahat sila ay constant lang yung extra space na ginagamit kasi usually counter lang yung mga kailangan niya. Aside from dun sa original na list, pero hindi naman natin binibilang yun sa space complexity. So, ayan, O of n, yung space complexity, nung particular na implementation natin na to. So, depende sa tinitingnan na resources nyo online, baka merong implementations na O of 1 or O of log n, yung space complexity ng merge sort, and that is because that is specific for their implementation. So, actually, yung aking implementation dito is medyo castarol siya sa space dahil dito sa left and sa right, but I'm assuming this will make it easier for you to understand yung ginagawa ng merge sort. So, ayun. Well, it will be true na kaya mong ibaba yung space complexity, but as long as you're using recursion, meron tayong extra space na ginagamit to achieve yung ating faster na time complexity. So, yun. Especially if madaming elements na kailangan i-merge, usually, go-to choice is merge sort kasi mas mabilis yung kanyang or mas mababa yung kanyang time complexity. Then lastly, we have our example or another divide and conquer algorithm na naghahanap na tawag natin na maximum sum array. So meron lang mga extra functions dyan to help yung pagpa-plot dito. So effectively, essentially, yung gusto ng maximum sum array is kuhain ko lahat ng consecutive na numbers na pag inad ko, yung total niya is maximum. So for example, in this array over here, pag inad ko yung elements dito sa itong 4 points na to, ang total niya is 43. And wala na akong makukuhang iba pang sequence of consecutive points na meron mas malaking total dyan. So this will be useful kung pag tumitingin kayo sa stocks or meron tayong na-maximize na profit. Ganun. So dun siya nagiging useful. So yung straightforward approach is to test every possible start and stop ng ating sub-array. So pwede kong piliin yung first 2, and then yung first 3, first 4, first 5, first n, and then pwedeng skip ko yung first, and then ayun, same process ulit. So essentially, starting with I equals 0, j equals I. So si I yung start ng array, I yung start ng current na chine-check mo, si j yung ending ng current na chine-check mo, and eventually yun, si j So initially I from 0 to j equals 0. So parang si I start siya kay 0, si j mag-start siya kay 1, and then eventually proceed siya hanggang n. After naman nun, si I may 1, si j may 2 hanggang n, si I may 2, si j may 3 hanggang n. So ito yung start, ito yung stop. And then, basically, chinek niya lang lahat ng possible na combinations para ma-search yung maximum na subarray. Kaya siya naging O of n squared. However, we can think of another divide and conquer approach for this, wherein, ayun, partition. So, gusto natin mag-divide. So, i-divide natin sa dalawa. So, saan may kita yung maximum subarray natin dito? So, obviously, yung maximum subarray, dapat makita natin siya dito sa left na subarray. If hindi natin siya makita sa left na subarray, kailangan nasa right na subarray siya, di ba? And if hindi pa natin siya makita doon, siguro nandito siya sa gitna. Ayun, ang kagandahan dito, pag nasa gitna tayo, sure tayo na meron tayong dalawang element na kasama. If meron tayong subarray na hindi sila kasama, dapat nakita na natin sila dito sa lower or upper. Kasi if hindi pala ito kasama, edi nakita na dapat natin yung maximum subarray dito. Tapos kung kasama pa, kung hindi naman ito kasama, kailangan makita natin yung subarray dito sa partition na to. Ngayon, if hindi natin nakita yung mga maximum subarray doon, kailangan kasama silang dalawa. So, naintindihan naman siguro yun. And then, ayun, since kasama na to, pwedeng i-extend ko lang dito hanggang makuha yung maximum. Extend ko lang din dito sa kanan para makuha yung maximum. So, ayun, yung code natin, ganito yung tsura niya. We get yung maximum subarray from lower to mid, or yung sa left. And then yung maximum subarray din sa kanan. And then yung maximum subarray din sa gitna. And then kino-compare lang natin aling subarray yung pinaka-malaki. Yung sa crossing, yun lang. Mag-start ka from the middle, extend sa kaliwa, and then extend sa kanan. And mahanap mo rin eventually yung maximum subarray na nagko-cross sa gitna. Complexity analysis, ayun, similar kay merge sort, meron tayong dalawang partition na ina-apply natin yung same algorithm, yung recursive call, and then yung time complexity no crossing. Yung time complexity naman sa cross, since mag-start sa gitna, extend sa kaliwa, extend sa kanan, at most that would be n steps. So that is O of n. So 2 times t of n over 2 plus O of n, similar lang siya sa merge sort. So makukuha mo yung kanyang time complexity ay n log n din. So mas mabilis siya doon sa initial na n squared na approach. However, meron din actually linear approach dito, pero hindi na siya part ng ating coverage. So yun, comparing the two, yung iterative na solution is n squared with constant space, and then C, divide and conquer ay log linear with logarithmic space. So, depende sa'yo. If kailangan mo ng mas mabilis na algorithm, usually divide and conquer can help you. Pero you have to be willing to sacrifice some space. Although meron nga implementations of divide and conquer na hindi kailangan ng extra space. Pero yun, kailangan siyang pag-isipan pa ng mas masinsinan. So parang yung burden ng pag-iisip, pwedeng nasa iyo or pwede mo ipasa sa computer. So ganun lang. And then, ayun, since sa divide and conquer, lagi naman ganun yung itsura. Nagde-divide tayo, nagko-conquer tayo, and then merge tayo. So yung kanyang recurrence relation, pwede mo siyang i-generalize to this form wherein T of n is equal to A times T of n over B plus F of n. So this is for yung hindi base case. Yung sa base case, O of 1. So given this relation, A yung number of conquered partitions, basically, B yung total partitions na ginawa, and then F of n yung ating merge operation or yung combining operation in the end na ginagawa. So for, ayun, given yung A, B, and F of n, depending dun sa relationship ng n raised to the log of A with base B, pag kinompare natin kay F of n, kung mas malaki si n to the log na term, yung ating time complexity ay yung n to the log na term. If equal sila, yung n to the log na term times log of n. And then if mas malaki si f of n, ang time complexity natin ay si f of n. So, not sure lang if kinover dun sa previous weeks. Theta, yung ginamit ng notation dito, kasi when we say theta of n, it means na si big O of n and si omega of n ay equal. So, ibig sabihin, same yung worst case sa best case. So, no matter ano yung input, yung ating time complexity is the same. So, yun lang yung ibig sabihin ng theta notation. So, ayan, if you plug in dun sa binary search, f of n is equal to a constant. And then, two partitions, isa yun na conquer. So, log base 2 of 1 is 0. N of 0, n raised to 0 is equal to 1. Assuming n is not 0. So, yung ating time complexity for binary search is log of n. And actually, pwede din natin kung i-apply dito. So, kung nag-advance reading ka, before mo gawin yung formative quiz, meron actually mabilis na solution dun sa ating items. So, kung ano ito yung master theorem dito sa kanan, and yung time complexity ay yung quiz dito sa kaliwa. Dito sa first item, dun sa quiz, yung A natin dito ay A natin dito is equal to 1. Ang B is equal to 2. And ang ating Fn ay equal kay n. So, yung ginakuha natin term, yung n log term, hindi ko alam kung may shorthand dyan. N log term. N log base 2 of 1. So, similarly, n log base 2 of 1 dito is equal to n to the 0th power. So, this is just 1. So, if we compare natin, si n log kay f of n, mas malaki si f of n. Therefore, ito siya, case number 3, we get that our overall time complexity is just yung f of n. So, f of n dito, siya lang din yung sagot natin doon. So, wow! Hindi na natin kailangan mag-drawing, hindi na natin kailangan maghanap ng pattern. Then this one, over here, si A ay equal kay 4, si B ay equal kay 4 din. So, yung n log term natin, n log 4 raised to 4 is equal to n to the 1. So, just n. And comparing n to our f of n over here, it's also n. So that is yung ating second case, wherein our time complexity is yung n log term times log of n, which is precisely yung ating sagot dito. So, ayun. Amazing. if you want proof nung master theorem, nandun siya sa book by Corman et al. CLRS. CLRS na. Pero yun, useful lang siya pagka ganito yung form ng ating recurrence relation. So pag naging ganito na siya, naging -1, well, babalik na dun sa dalawang methods na nabanggit na. So ayun, that is the material for week 4. So basically, it's just a bunch of examples that show yung paggamit ng divide and conquer and yung ating analysis ng kanilang time and space complexity compared to other approaches. Kung better ba sila or worse. So in terms of time, usually nag-improve, and then in terms of memory, usually naging worse. Pero yun, depende pa rin doon sa problem if that would be true. Kasi merong mga ibang problems na hindi talaga fit for divide and conquer. And meron din mga problems na fit talaga. Pero yun, going back, siguro what's left for us now is yung assessment sa week 4. So for week 4, you have a summative quiz and a coding exercise. So yung summative quiz, siguro preview, mga 20 points siya na parang matching type. And then 40 points siya na essay. So be sure to, well, hindi naman ako strict na kailangan straight English yung essay. Pwede rin hindi. Pwede kayo mag-attach ng figures and drawings or actual code if you need to. Pero, ayun. So similar, yung essay, type of essay, similar din sa nakita niyo last week, yung last question. Paano mo siya i-improve? Magko-compare kayo ng dalawang algorithms, basically. And ayun. And then for the coding exercise, naka-open ko siya dito. Siguro preview na rin natin siya if meron kayong questions as of now. Pero most likely, yung mga questions nyo tungkol sa coding exercise, darating sila next week. Although don't worry, kung medyo na-behind kayo ngayon, ang topics next week ay linear na data structures, which is arguably yung easiest topic sa EEE 121. And ayun, kaya actually siya ng isang meeting, isang 1-hour session. Kaya hindi na ako mag-require or hindi na ako gagawa ng synchronous meeting next week. Most probably next week na ulit when na-introduce na yung mga non-linear data structures. Pero yan, ito nag-load na ang ating coding exercise for week 4 is, ayun, may konting kwento lang sa umpisa para hindi. I hope na-appreciate niyo pag gagawa ko ng kwento sa mga exercise. Pati ako natatawa sa sarili ko sa mga ginagawa dito. Pero anyway, yung kailangan nyo lang talaga dito is itong dalawang lines na to. Find the sequence of consecutive rows where yung difference of the elements sa odd numbered rows and yung elements sa even numbered rows are maximum. So keywords dito, consecutive rows and maximum. So supposedly may idea na kayo nung kailangan yung gamitin for this exercise. And may additional lang na hanash dito sa dulo. You get the first number of the first row and then the second element ng second row and so on para makuha yung output sequence na hinahanap ng checker. So for example, yung input natin, yung first number is yung number of rows and columns. And then yung input na grid. So for example, dito is 5 elements. Tapos starting with 10, 23, 16, 25, 12. So in the first row. And then 19, 11, 8, 1, 4. Next row. So basically meron tayong grid dyan. And then nahanapin nyo lang yung consecutive rows na maximum. Yung difference between yung odd numbered rows and yung even numbered rows. So pag in-add ko to, and kinompare ko dito, ang makukuha ko dito is malaking difference. So, pwedeng positive, pwedeng negative na difference, pero malaking difference. So, apparently, itong tatlong rows daw, yung consecutive rows na yun, na maximum yung difference. And ang hinahanap na output sequence is yung first element ng first row, second element ng second row, and then third element ng third row. So, ang ating output ay 10, 11, and 9. Then we have another case here na, ayun, 10 by 10 naman siya na grid. And you can check yung mga alternating rows and alternating rows, yung total sila, compare each other. And you should get na itong tatlo, yung may maximum difference. And ito, yung first row, second row, third row yung nahanap yung output. So basically, kung yung total nito, and then add mo sa total nito, subtract mo sa total ito sa gitna. Kung gusto niyo siyang i-extend, ito, i-add mo dito. And then i-compare. Kung lumaki yung difference, sama mo siya. Pag hindi lumaki yung difference, huwag mo siyang isama. And then, pwede mo din dagdagin pa ito dito. Ito din, dagdag dyan. And eventually, makikita nyo na yung pinakamalaking difference kung tatlong magkakasunod dyan. And ayun, may option kayo to do it in Python or in C. Pero, ayun, kayo naman nabahan. And I think, yun. Ang constraint lang natin dito, you should have a log linear na worst case time complexity. Without, hindi kasama yung input kasi yung input, pagkuha pala ng input is n squared na. So apart from that, yung other parts ng algorithm should be log linear time. So, and are there any questions? Wala naman ba? So I guess that will be all for this week. Yun, so direct message na wala ng questions. And ayun, I'm assuming darating yung mga questions pag ginagawa nyo na yung mga activities. So message nyo lang ako or message nyo lang si Kuya Brian, ating SA. And ayun, thank you very much for attending. Thank you for your time and have a nice evening. Okay, bye-bye.